Okay, so now we've been talking about exposure in the previous episode and how stops relate to changes in exposure and what that looks like. And now we need to put that bit into practice with something we call equivalent exposure. So, equivalent exposure, what exactly is that? Well, first we need to think a little bit more about what a stop really actually is. So, a stop is useful because you can translate aperture, shutter speed, and ISO units all into stops. And a stop is always the same amount of light. So it represents a discrete entity of light coming into the camera. And the way that the units are set up for ISO, shutter speed, and aperture makes it such that um, we can swap the stops between all of those three uh, types of exposure changes that are happening in the camera. So one aperture stop is equal to one shutter speed stop, which is equal to one ISO stop. So here's the idea of equivalent exposure. You can have various aperture and shutter speed combinations that result in the same exposure, i.e. the same total amount of light is let into the camera through the visualization, though the visualization of the scene is different. If you use stops, it's easier to understand. So in this graphic, what we have is three pictures of the same scene. They don't look exactly the same, but what we can agree on is that overall, the tonality or the overall exposure of the scene is the same. In one image, there's a lot of blurriness of the pigeons moving around, but we have a lot of depth of field and can see near to far, all in focus. And then over on the right, we've got the pigeons stopped in action, but we have a much blurrier background. So we're not getting the same exact picture, but we are getting the same exposure. And so if we look a little closer at the three exposures of those photographs, one was taken at f16 and 1/8 of a second, so very long exposure, but a very small opening that let in the light into the camera through the lens. And then we have one in the middle, which was photographed at f4 and 1/25 of a second. And then all the way on that right was a really wide aperture to let in a lot of light through the lens, but a very short shutter speed time of 1/500th of a second. So each shutter speed and aperture combo here give the same overall exposure. The adjustments and counter adjustments are made so the overall exposure stays the same. Or we can look at the bottom and say, if you add a stop in one place, say an aperture, but then you take a stop away in another place like shutter speed, the result in exposure is no change. And that's what we mean when we're talking about equivalence or equivalent exposure. The two choices we made and the two different photographs could be different, but the exposure of that same scene ends up being the same. So let's take a little bit deeper dive into that and see what that looks like. So here we have two pictures, and they both have slightly different settings that were used, but we can look at say the flower in the middle, and we can agree that the flower, the pink, the green of the leaves, it all has the same exposure value, right? It's about the same color, it's about the same darkness or brightness overall. Then, so on the left image, it was taken at 1/1000th of a second for shutter speed, and the aperture was 1.4, and the ISO was 100. And then on the one on the right, ISO did not change, but the shutter speed and the aperture did. So the shutter speed for the one on the right was 1/500th of a second. Okay, so the exposure was twice as long, and the aperture though was a little bit smaller than the one on the left. It was f2.0, right? Which actually, by the units, means that half the amount of light was let in through the aperture, but the time that the that the camera was exposed was twice as long. So just a little at the bottom there is some math check. So like 1/1000th plus 1/1000th of a second is equal to 2/1000ths of a second. And that could be reduced to 1/500th. All of that just goes to show you that the 500th of a second is twice as long as 1/1000th of a second. It's actually equal to 2/1/1000ths, right? So this is really the heart of equivalent exposure. And we can extrapolate this out a little bit wider by saying here, what we have is, again, all of these images are the same. And 1/1000th of a second all the way down to a 30th of a second, very different shutter speed times, but because we've counterbalanced that by decreasing the size of the aperture opening each time, we are offsetting that change in shutter speed with the change in aperture so that the overall exposure remains the same. And you can see here I've gone in and I've shown you as we move from one image to the next, here we've doubled the time, but we've reduced the amount of light coming in by half. And here we've done this again. We've quadrupled the time because we've doubled it one more time, 1/250th of a second compared to the original, but we're letting in only a quarter of the amount of light of this. And so these are kind of working in powers of twos. So, so when we get down here, we've multiplied the amount of time by 8 because we've doubled it 3 times, doubled, and doubled. 2 times 2 times 2 is 8, and so on and so forth. But the result, again, is that we have all the same exposure. We just have chosen how to make that exposure differently with, in this case, by adjusting shutter speed and aperture. So here's another way of looking at the same thing. If we're thinking about our aperture scale up top here from f1.4 to 2 to 2.8 to 4 and so on all the way up to f32, we see that resulting change. So let's look at just aperture specifically when we're talking about exposure changes and stops. So if we are changing the aperture from f5.6 to f4, from here to here, we're adding one stop of light because we're opening our aperture up, so more light's coming to the camera. You can think of this as going from, like, say, X to double X. Whereas if we're changing the aperture from f5.6 to, say, f8, we're going in the opposite direction. So in this case, we're closing down the aperture one stop. So we're removing one stop of light from the camera. And we could think of that as halving the amount of light, or if we had X as the amount of light, then it would become half an X, okay? So the ultimate idea of equivalent exposure is to retain the same exposure. You have to end up with no total change in light. So let's think about this. And this time, I'd like you to sort of see if you can figure this out for yourself. So here we have in the aperture scale and the shutter speed scale and the ISO scale all kind of stacked together here for the purpose of understanding this. So if you go from the aperture f2.8 to aperture f5.6, right, you're going to be removing 2 stops of light, right? So you're going from f2.8 up here to f5.6. It's getting smaller, and we're removing 2 stops of light. That's the same as reducing it by a quarter. So here's my question for you. To retain the same exposure, you have to end up with no total change in light, right? So what shutter speed would you compensate this aperture change with, right? So what shutter speed would compensate this change in aperture from f2.8 to f5.6? So if you chose that if you went from 1/250th of a second down to 1/60th of a second, you're correct, because that is the same as adding 2 stops of light back into the camera, which would offset the quartering of light by essentially quadrupling the amount of light that comes back in. So if you take a quarter of the light, but then you add back, then you multiply it times 4, then you'll be back to the original amount of light that you had. Another thing to just know is that stops are also called exposure value, and we often split stops into 1/3 or half or full stop values. The full stop values of each of the units that we use for, say, aperture or shutter speed or ISO, it's important to understand those typical numbers because those are like roadmap or like signposts on the roadmap for you to kind of know where you're at and what's changing. But I also want you to be able to recognize 1/3 and one stop values, at least being able, if you don't know the number, you can at least sort of understand, is that halfway in between, say, F8 and F11? Okay, then it must be halfway. Is it maybe just a little bit more than, say, F8, like F9? And kind of understanding where you're at in that scale. So the most important thing is that you learn these full stop scales for aperture, for shutter speed, and ISO. That's going to take a little bit of memorization and just brain power for you to sort of to rationalize what they kind of are telling you and what they mean. So these, if you do these that I have here, then you're going to be in good shape. Remember, for the aperture, we're talking about f-stop scale, which is probably the hardest of them to understand because the numbers seem a little bit arbitrary and don't necessarily follow the mathematical idea of stops, which is either doubling the amount of light or having the amount of light, right? Shutter speed's a bit easier because it's just about honestly doubling or having based. So let's look at these just a little bit further. So here's our aperture scales. And here in bold, we can see our full stop values from f2.8 to f22. And then you can see on the left-hand side, the half f-stop values. And then on the right, you can see the third of a stop values in between the full stop scale. So, and again, you don't have to memorize all of these numbers. That's not the goal. But you do need to know the full stop, the numbers in bold, so you kind of understand what that going from f2.8 to f4 is a doubling. It's not so important that you understand that exactly that, it's f2.8, then f3.2, then f3.5, then f4, and so on. But you need to have a pretty good understanding of where you're at in this range, and those full stop scales really are the things that you need to focus on. In ISO, sorry, this should say aperture stop scales. This should say shutter speed stop scales. You've got we've got in bold again our full stop scale: 30th of a second, a 60th, 1/25th, 2/50th. You can see sort of how these are getting faster and faster each time as we go down. It's twice as fast, which means half as long of the exposure, right? So it's letting in half as much light as we're going down here, because a 1/1000th of a second is half as long as 1/500th of a second. Okay, so again, just kind of getting a sense of, okay, if I see a number from my camera being thrown at me of 1/320th of a second, that I at least know that's between a 2/50th and a 500th of a second, and it's probably a little bit closer to 2/50th. And then lastly is our ISO scale. So we have an ISO of 50, 100, 200, 400, 800, 1600, 3200. We are doubling our numbers, and every time we double our numbers here, we're doubling the sensitivity to light, which means we effectively are doubling our exposure when we're going up, when we double our ISO number. Um, and here we have the half stops again on the left, and the third stops values between our full stop values.